Today we are going to learn about AI agents for precision irrigation systems. We will explore how AI optimizes water usage in agriculture, ensuring sustainable farming while maximizing crop yield.
Welcome to our comprehensive exploration of AI agents in precision irrigation systems. Precision irrigation is a method that applies water directly to the root zone of plants, conserving water and boosting efficiency. In sustainable agriculture, this technique is crucial for reducing water consumption and enhancing crop yields. The integration of AI into these systems represents a significant advancement. AI agents can analyze data, predict weather patterns, and make real-time adjustments, ensuring optimal water usage. Today, we'll delve into how AI transforms irrigation, the methodologies it employs, and the tangible benefits it brings to agriculture. By the end of this video, you'll have a thorough understanding of how to effectively implement these technologies in your farming practices.
Precision irrigation is an innovative approach tailored to supply water directly where it's needed, minimizing wastage and promoting plant health. This method involves using technology to monitor soil moisture levels, plant needs, and environmental conditions. By doing so, it ensures that water is applied at the right time and in the right amount, maximizing the efficiency of water usage and enhancing plant growth. The primary components of precision irrigation systems include sensors, controllers, and delivery systems, each playing a crucial role in maintaining optimal soil moisture levels. These systems not only conserve water but also reduce energy costs and minimize environmental impact, making them an essential tool in sustainable agriculture. AI technology is revolutionizing precision irrigation by enhancing its efficiency and effectiveness. At the core of AI's role is its ability to analyze vast amounts of data collected from various sensors. These include soil moisture levels, weather conditions, and plant health indicators. AI algorithms process this data to create predictive models that inform irrigation schedules, ensuring that plants receive the right amount of water at optimal times. Furthermore, AI enables the automation of irrigation systems, reducing the need for manual intervention and human error. This automation leads to more precise water distribution, enhancing crop yield and reducing resource wastage. By leveraging AI, farmers can make informed decisions that align with both environmental sustainability and agricultural productivity.
Soil moisture analysis is a critical component of precision irrigation, and AI plays a pivotal role in optimizing this process. By utilizing sensors placed throughout the field, farmers can gather real-time data on soil moisture levels. AI agents process this data to determine the specific water needs of different plant areas. This analysis ensures that water is distributed efficiently, avoiding both under- and overwatering. Moreover, AI-driven soil moisture analysis leads to improved crop health by maintaining optimal growing conditions. The result is a more sustainable use of water resources and enhanced agricultural productivity. AI's capability to process and analyze data in real time provides farmers with actionable insights, which are vital for strategic decision-making in irrigation management. Integrating weather forecasts into irrigation planning is an essential aspect of precision agriculture. AI agents utilize predictive analytics to incorporate weather data, including temperature, rainfall predictions, and humidity levels, into irrigation schedules. This integration allows for adjustments in irrigation plans, ensuring water is used efficiently. For instance, if rain is forecasted, AI can delay or reduce irrigation, conserving water resources. This capability enhances resource efficiency and ensures plants receive the right amount of water at the right time. By leveraging AI-driven weather forecasts, farmers can optimize irrigation schedules, leading to better crop yields and reduced water wastage. This integration is a testament to the power of AI in creating more sustainable and productive agricultural practices. AI systems excel in real-time monitoring and adjustments, a critical feature that enhances the effectiveness of precision irrigation. Through continuous data collection from field sensors, AI agents dynamically adjust irrigation schedules and water distribution. This real-time decision-making process minimizes the need for human intervention, reducing errors and increasing efficiency. AI's ability to make quick adjustments ensures that plants receive optimal water levels, even as conditions change. This adaptability is particularly valuable in mitigating the impacts of unexpected weather changes or equipment malfunctions. By improving system efficiency, AI-driven real-time monitoring contributes to sustainable water management and enhances agricultural productivity, demonstrating the transformative potential of AI in modern farming.
Real-world case studies highlight the tangible benefits of AI-driven irrigation systems in agriculture. For example, a vineyard in California implemented an AI-based irrigation system that led to a 25% reduction in water usage while increasing grape yields by 15%. The system utilized soil moisture sensors and weather forecasts to optimize water distribution. In India, a rice farm adopted AI technology to manage irrigation, resulting in a 30% increase in crop yield and significant water savings. These case studies demonstrate the potential of AI to improve agricultural productivity and sustainability. The lessons learned from these implementations include the importance of customized solutions and the need for continuous monitoring and adjustments. These successful applications underscore the value of AI in transforming traditional farming practices into more efficient and sustainable operations.
Despite the benefits, implementing AI in irrigation systems presents several challenges. Technical hurdles include the complexity of AI technologies and the need for reliable internet connectivity, particularly in remote farming areas. Cost considerations are significant, as the initial investment in AI systems can be substantial. Effective data management is crucial, requiring robust systems to collect, process, and store large volumes of data. Additionally, farmers need training to adapt to new technologies, which can be a barrier to adoption. Infrastructure requirements, such as installing sensors and communication networks, also pose challenges. Addressing these issues requires collaboration between technology providers, governments, and agricultural communities to develop practical solutions that facilitate the widespread adoption of AI in irrigation.
The future of AI-powered water management holds exciting possibilities, driven by emerging technologies and advancements in AI. A key trend is the integration of AI with the Internet of Things, IoT, creating smart irrigation systems that further enhance efficiency and precision. These systems will leverage real-time data from various sources to optimize water usage and improve decision-making. The focus on sustainability will drive innovations that reduce water consumption and environmental impact, contributing to global efforts to combat climate change. AI advancements will enable more sophisticated predictive models and automation, offering farmers more control over their irrigation practices. As these technologies become more accessible, their global impact will be profound, transforming agricultural practices and promoting sustainable resource management worldwide.
Deploying AI in irrigation systems involves several practical steps to ensure successful implementation. Firstly, it's essential to assess the specific needs and goals of your agricultural operation, considering factors such as crop type, climate, and available resources. Choosing the right technology is crucial, requiring research into different AI solutions and their capabilities. System integration is a key step, involving the installation of sensors, software, and communication networks. Providing training and support to farmers and staff is vital to ensure they are comfortable with the new technology and can maximize its benefits. Finally, continuous evaluation and improvement are necessary to adapt the system to changing conditions and enhance its performance. By following these steps, farmers can effectively deploy AI in their irrigation systems, leading to improved water management and agricultural productivity. In conclusion, AI agents represent a transformative force in precision irrigation, offering significant benefits in water management, crop yield, and sustainability. While the implementation of AI presents challenges, such as technical and cost considerations, the potential rewards in improved efficiency and productivity are substantial. As we look to the future, the integration of AI with emerging technologies promises to further revolutionize agricultural practices. We encourage farmers and stakeholders to explore AI solutions as a pathway to sustainable and profitable farming. By embracing these innovations, we can ensure a more sustainable future for agriculture and resource management.